Alright, let's have a look at some trigonometry. Now, trigonometry is actually looking at all ratios and angles in right angle triangles. So the big thing with trigonometry is remembering SOHCAHTOA. We have three things: sine, cosine, and tangent, or sine, cos, and tan. Remembering SOHCAHTOA is important because sine is going to equal the opposite over the hypotenuse, cos will equal the adjacent over the hypotenuse, and tan equals the opposite over adjacent. Now, what does all this mean? It's simply referring to the positions and values around the triangle depending on where the angle is. So let's look at this as an example straight away. We see our angle here is 68 degrees in this corner. We're supposed to find x over here, and we've been given the hypotenuse that is opposite the right angle of 13 centimeters. So the first thing I do whenever I'm working with trigonometry is I label where all of my different things are. So I said this was the hypotenuse, so I'm going to put a H there because it's opposite the right angle. Opposite this angle here is x, so that's going to be opposite, alright? And that leaves the one side remaining as the adjacent side to the angle. Now, I examine this here and I see what I have and what I'm looking for. Well, I'm looking for sine, cos or tan that uses opposite and the hypotenuse. Now, I can rule these out straight away because these both rely on having a value or finding a value for the adjacent angle here. Adjacent and hypotenuse, opposite and adjacent. So I instantly know that sine is going to be what I'm going to use because sine of this angle here, which I'm going to call beta for now, is equal to opposite divided by the hypotenuse. In this instance, sine of 68 degrees is going to be equal to opposite, which is x, or what we are trying to find, divided by hypotenuse, which we know to be 13. I've got opposite and I have hypotenuse. Now, we are trying to single out x in this instance. So, we're dividing by 13 on this side. We need to multiply by 13 on this side to get rid of it. So to balance it up, we do it to the other side. I'm going to write my x on this side here because we're balancing it up. And so I have sine of 68 degrees multiplied now by our 13 centimeters here. Now, to do this on the calculator, I simply need to find my sine button of 68 multiplied by 13. And that leaves me with 12 point, if I was rounding up, 1 centimeters. Now, we could check this, put this in here, and check it using Pythagoras, but that's how it works in that instance. Heading over this way to the second example, you can see we want to find out what this angle is here. Doesn't matter, we can still use trigonometry for that. Okay, we just need to look at what we've been given. So the first thing I do in trigonometry is I label my sides. Over here is going to be opposite the angle I'm looking for. It's straight across from it. I know that this here is going to be my hypotenuse because it's opposite the right angle and the longest side. So that must mean this here is adjacent. So let's look at what we've got. We have 11 in the hypotenuse and 7 as adjacent. So I want to find a rule here that uses hypotenuse and adjacent. No, that's using the opposite. Hypotenuse and adjacent, opposite and adjacent. We're not using the opposite, so that must mean I'm using the cosine rule. So in other words, cos beta equals adjacent over hypotenuse, as we can see here from SOHCAHTOA. So if I'm substituting in my values in this case, I have my adjacent angle, which is 7 centimeters, my adjacent length, sorry, and my hypotenuse as 11 centimeters is cosine of beta. So what I want to do to get the angle from this point is, I could straight away convert that to a decimal value. So if I went 7 divided by 11 is here 0.636. We'll use 3 decimal places. Now, that's a decimal. That's not going to help us with angles. What we need to do is find the inverse cos. So if I press Shift cos, you'll see a little -1 at the top. That means we're going from decimal to an angle. And I put in 0.636 and hit equals. We have 50.5 degrees. So that must mean that the cosine of beta is going to be 50.5 degrees. So we know this angle in here is now going to be 50.5 degrees. And that is how you use trigonometry on to find a missing length and also an angle.